This is simply unbelievable. In order to solve the problem of unstable voltage that often occurs in rural areas of Pakistan, this high-tech method located in Peshawar is to use self-taught high-end electronic technology to rub hands and make a fully automatic high-power voltage stabilizer that can stabilize 80 volts to 260 volts AC into 220 volts AC. And these seemingly ordinary iron sheets are actually the important raw materials used to make the pressure regulator. Silicon steel sheet workers will use a shearing machine to cut the silicon steel sheet into standard sizes and then put it into a punching machine to punch out a suitable shape on the silicon steel sheet through a punching die. Next, you need to use a shearing machine to split the silicon steel sheet into two so that it can be quickly made into a silicon steel sheet of the same type. Then you need to start making the transformer coil. Workers will wrap a few turns of paper around the aluminum block. This not only makes it easier for the finished coil to quickly removing it from the aluminum block, can also ensure that the insulation layer of the coil will not be damaged. The winding of the coil is completely done manually. Each layer needs to be wrapped with a layer of paper as an insulating material. In order to make a high-efficiency power stabilizer, high-quality copper wire naturally becomes the best winding material. Since the function of the transformer is mainly to step up and step down the input voltage, the voltage regulator is designed with 80 volts to 260 volts. The wide voltage input range requires multiple taps on the coil so that the main control chip can select the corresponding coil tap according to different input voltages so that the output end can output a more stable point voltage. After the coil is wound, the worker will embed silicon steel sheets on the coil. By staggering and stacking the special-shaped silicon steel sheets, the structure of the entire transformer core can be made more compact, and at the same time, the magnetic circuit closure of the entire transformer is more complete. But due to the staggered stacking method, a certain amount of gaps will appear in the silicon steel sheets. So it is necessary to embed the previously cut and bleeding scraps of silicon steel sheets in the gaps. Next, the silicon steel sheets need to be tightened. Workers will use two brackets to tighten the transformer core and then use multiple connecting plates to tighten the brackets at both ends to fix them. In this way, it can form a solid whole. After the transformer is manufactured, the assembly of the whole machine can begin. The workers will assemble the manufactured voltage stabilizer frame. First, the front and rear panels need to be assembled together with screws. Then glue is applied to the front panel and the pre-printed panel film is pasted on the panel. In this way, the grade of the whole product is instantly in line with international standards. Then some holes for the installation of accessories need to be opened on the panel film with scissors. Then the formal assembly can begin. The first thing to install is the indicator light, followed by the input and output stacking meters, followed by the output socket on the back, and then a power cord needs to be inserted and connected to an empty used to control the start of the voltage regulator. Then use an electric pick to make corresponding connections to the instrument. Next, you need to install the transformer. The worker will put insulating sleeves on the wires of the coil tap one by one, and then use screws to firmly fix the transformer in the outer shell. Then you need to connect the main control board of the voltage regulator. The function of this board is to detect the point voltage of the input section at any time and calculate the difference with the output terminal 220 volts. Then the main control chip controls the relay to select the corresponding miscellaneous tap of the transformer and then adjust the voltage through the appropriate miscellaneous pin. The worker will weld the corresponding coil tap to the corresponding position of the board and adjust the distance between the wires, and then the voltage regulator needs to be debugged. By adjusting the value of the adjustable resistor, the point voltage in the return circuit is adjusted to determine the preset value for triggering the tap switch. In this process, the input voltage needs to be manually increased from 80 volts to 2.60 volts to test whether the output terminal can always be stabilized at 2.20 volts. After the voltage stabilization test is successful, the board can be fixed in the corresponding position and then assembled. It is carefully packaged. So after watching the whole process, what do you think of the quality of the power regulator made in this way?